Thank you so much, Catherine. And while my colleague, I think there were some issues with that, but I think it's a good segue into what I'm about to present, more so from the perspective of technology intervention that is required for marine spatial planning. Um, the idea here, and as I'll keep explaining in the upcoming slides, is that what we need as a country, specifically in the global south, is more so from the perspective of modeling and simulation driven work, which includes analysis and data sharing, and essentially a tool that connects multiple organizations together and avoids creating siloism. But before we get into that, and before we try to identify how a tool or a technology in essence helps us solve problems, um, let's look at the problems that we currently have. These are just two examples. There are much more, but we can see in the past there have been instances like, for example, with the Birmingham Port project that happened. There was a massive amount of protest that was staged after the construction of the port because that led to a lot of accelerated coastal erosion. All the communities were displaced, the fishing zones got displaced. There was a large scale dredging that happened because for that particular port construction, which ended up destroying the complete ecosystem in the region. And a similar one, but a kind of slightly with a different objective, due to erosions happening in the coastlines. The I think this happened back in Tamil Nadu. They ended up placing some drawings and seawalls at the end of seabed. What that did, then that kind of solution completely ignored sediment dynamics on how the sediment flows. What that did, it just shifted the problem downshore to a different region, and did not really fix the problem per se. Now, the World Bank report from 2020 on enhancing coastal and ocean resource efficiency project that specifically mentions that one of the biggest problems that we have is that multiple agencies are operating in silos with unshared data sets, leading to uncoordinated decisions. And because it is a disjoint approach that we are taking, there's a lot of information gap. We are missing a lot of early warnings. We are not able to formulate an integrated marine plan due to limited data sharing and technical capacity. So every organization, every agencies work in silos without having an understanding of what's happening in the other side of the spectrum. A port construction will not have an understanding of what's happening from a marine conservation perspective, and so on and so forth. So what we are kind of suggesting in terms of the technology intervention for MSP is to solve such kind of a problem, a platform essentially that converts raw observations into actionable insights for policy, conservation, and industry. And it goes beyond a static. So marine spatial planning as a concept, when it was introduced, if I remember correctly, in the early 90s, it was introduced when the Coral Reef project happened for the Great Barrier Reef in Australia. It started from there, and ever since then, it has been substantially been improving, but still it remains to be a static map. The idea being that with all the data that you obtain, be it AIS data or ports in the region or offshore oil rigs and platforms, you essentially map everything, all the static data onto a particular tooling, and that allows you to have a broader overview of what's happening in the what are the different resources that are present in the ocean. What we are suggesting is something a bit different. What we're suggesting is that beyond just having a static map, we need to analyze the data, we need to take actionable inputs out of the data, and then we need to showcase that. So instead of just showcasing AIS data in the region, we essentially derive shipping noise that is derived from the AIS data. Instead of just showcasing acoustic habitat, instead of just showcasing, sorry, marine habitat, let's say for whales, sea turtles, we also capture the migratory patterns, we also capture the migratory corridors. And these information, when come together, they provide actionable insights because you can effectively see how the shipping noise is directly impacting the marine habitat, and so on and so forth. So what we are actually looking at, and as Sir mentioned, this is something that we've been working on, although still in preliminary stages. There are a few components that are left to be addressed here, but idea here is that we want to create a marine spatial planning decision support tool which goes beyond the existing MSP tools that are available, at least from the Indian subcontinent perspective, where you get actionable data, and those data, when I say again, it does come to a point where not every information is already available in terms of raw recordings. So not every information can always be obtained in raw recordings. So a lot of these things are actually simulated. And I'll draw back from what Catherine has mentioned there, in the sense that being a global south, we cannot always end up spending in blanket exposure of hydrophones or sensors. We cannot put up that kind of money. So we need something that can work for us. We need something that can work for a solution that will work for our subcontinent. So what we're looking for, looking as is a single system where we have all the different planning layers coming together, being habitat suitability model, marine biodiversity, in all the different kinds of noise calculated and showcased in the map, wind noise, rain noise, shipping noise, and a lot of different things like pipelines and cables, in order to understand what kind of risks and what kind of mitigation practices we need to take for undersea cables that are flowing through the region. If at all we want to perform kind of drilling or offshore oil rig construction. So a single platform that showcases all that information. And deriving back from what the examples that I showed before, it is not that the agencies are not making an effort to, or it is not that they're undermining the impact of the work that is being happening, but rather that there is no broader overview between two different agencies of what's happening and how it might impact the other agency, and that is what we are trying to bridge here. So what we are here representing as a simulation-based MSP has two transformative advantages. One is dynamism, so it will continuously adapt to changing marine conditions and stakeholder needs. And second is the impact modeling, which is probably the more important aspect of it, which allows us to identify a what-if scenarios. So if you provide AIS data and taking all the other aspects into consideration, and if you overlay that on top of a habitat map, you can see what kind of noise level is there in the region. And if you provide a different set of AIS data, which essentially has different shipping lanes, so we're trying to shift the shipping lanes a bit, and that can instantly, you can see and visualize what kind of noise levels are there again because of the shifted shipping lane. And this kind of project is something that has happened in the past as well, although not in such kind of a scale. I remember off the coast of Sri Lanka, they identified that the blue whales were there was collision of ships with blue whales, and they identified that by shifting the shipping lane by 15 nautical miles, they were able to reduce the risk of collisions by around 95% for the blue whales. So it is definitely an action item that we need to take as a country as well. So what we are trying to showcase here in simulation-based MSP is we gather, so it is supposed to be enabled with real-time and historical data streams. So all kind of biodiversity, habitat data, AIS data, human activities, infrastructure, ports, cable, defense, everything that comes in there. And we place that on top of simulation engines. These simulation engines, again, it varies from application to application, depending upon what we are looking at. If we are, let's say, for example, ship noise estimation, we are looking at feeding in AIS data, and then we are grabbing the sound speed data based off temperature, salinity, pressure. We are taking sediment type, what kind of sediment is there, to identify the absorption coefficient and so on. We put that through a mathematical model, be it for India, probably it will be a parabolic equation based models that will allow us to estimate better, and so on and so forth. And that then you put it through an impact analysis and scenario testing, where you can create different scenarios and identify what kind of impact that is being generated, and all of that being represented in a decision support interface, where we extract information out of what we have analyzed and showcase it to the stakeholders for their consultation. And that, again, this a crucial part of this, what we are making is a community engagement aspect, where as a community, be it fisher folks or coastal or policy people or everyone, they can engage with the tool, they can provide data, they can extract information, public APIs that can be used along with other such kind of tools, let's say some digital twins or something that needs to gather information from us, a public APIs that can be allowed to extract information through that and ingest into their own tooling for better identification and visualization and so on. So that is the kind of a broader approach we are looking at when we look at the MSP as a digital tool. Now, the foundation for any such kind of tool is to be able to recognize the large amount of information that we need to process, the whole ETL pipeline or extract, transform, and load pipeline that we need to establish for that. Because depending upon the application, currently the MSP tool that we're generating consists of 7 different modules. Each of the different modules have a lot of different data requirement that we extract. Like say for urban flood mapping that we have done for Brahmaputra regions, we're looking at identifying the rainfall, the digital elevation model, the drainage data of that particular region, the land use, all the so on and so forth. If you're looking at acoustic habitat mapping, we need to understand the chlorophyll level that will tell us which habitat is more suitable. Then oxygen maps, the primary productivity regions for that, sea surface temperature, and so on and so forth. So all of this information, depending upon the different models we are ingesting, and we are essentially creating an ETL pipeline that will then transform it into what independent applications would require. And then, so it's not one tool which does 7 different parts of the work. These are basically 7 different backend services, which essentially perform their own computation. It sends the data to one particular tool, and that's what we are trying to promote here. In terms of showcasing from an application perspective, where it would look like. So imagine if we have a storyboard, a scenario where you want to identify that what kind of for a given shipping in the region, what kind of habitat are we trying to look at? Like how is the habitat getting impacted because of that? So you can essentially overlay the AIS data of the current AIS data. It could be a cumulative noise map, or it could be an instantaneous, depending upon the need, depending upon what we are looking at. So yeah, so we've got the AIS data, then we can overlay a map of shipping noise on top of that, which is again computed dynamically. A part of this computation dynamically again, and I'll talk about it as we move forward, is that this was not something that we were able to do because of I would consider because of less pronounced usage of AI as a model, but today with use of neural networks, so we basically replaced a parabolic equation model. So we basically created a neural network model which is suitable for the specific Arabian Sea, Bay of Bengal, and some southern part of IOR, which is trained upon the data that we have collected, as well as some data populated using the PRAM model that the transmission loss data that we populated using the PRAM model. And what that allows us to do is that instead of the computational time comes down drastically. So instead of it taking uh, instead of taking it n times to perform some computation, you are reducing it to log n, and so on and so forth. So the computation times come down drastically. Definitely, there is a trade-off with accuracy. However, depending upon the application, the trade-off is acceptable, provided you have a more dynamic mapping generation that is happening there. So for most of the applications that we identified, the trade-off is substantially like 5 to 10% of trade-off in accuracy is acceptable from what we saw. Now, from the noise map that we essentially have, we then overlay that with the acoustic habitat map. Again, this is something that we generated using a Maxent model that performs the habitat suitability mapping. Let's say for green turtles, which is mostly having a habitat near the coastal regions, we can see that there is a significant overlap between so some of the areas where there's an increased shipping, as well as the areas where the green turtles can be found, or a habitat where the green turtles can be found. Yeah. And what we're trying to look at here essentially is not just about showcasing the habitat at that particular instant, but also being able to identify the migratory patterns of the species. Right now we're looking at green turtles, blue whales, and dolphins. And what is the migratory pattern with respect to different seasons? What is the migratory pattern with respect to different environmental parameters? And how that helps us to identify all the projects, all the economic projects that we are taking up. And in terms of the analysis, so once we have this kind of a data, once we have performed that overlapping, we can give more actionable insights to the user instead of just saying that, okay, you have the shipping and you have a habitat map. You can extract the shipping noise and you can perform that overlapping analysis and identify that 94% of the habitat is between the green turtle and the shipping is overlapping, and so on and so forth. Now, of course, shipping noise is not the only aspect that we're looking at. Sediment management is also an extremely important component here. We have done some work in terms of data collection and sediment classification. We've developed a model for sediment classification for freshwater system as well as the tropical water systems. The idea here again is that all these components will come together in terms of sediment management. Sediment dynamics affect the estuaries, river mouths, and shipping channels globally. So it is extremely important that we identify it. We need to understand the flow of the sediment to be able to understand what is the type of sediment. We can perform a sediment classification, and what is the usage of that sediment. A clay silt will have a different usage as compared to, let's say, just a clay or a sandy clay sediment type. So being able to understand that, being able to understand the sediment transportation allows us to plan better, as I showcased with the example of the Puducherry uh, coastal erosion project that took up. Shipping noise we've already spoken about. We have done some work on top of that for noise and vibration studies. Um, Skip that one. Acoustic habitat mapping. Again, so the marine biodiversity, it goes beyond just the three aspects of uh, green turtles, blue whales, and dolphins. We are looking at other aspects like such as what are the different fishing zones, what are the different fisheries, identifying those and creating models that can help us identify the migratory patterns and establish the regions of those particular turtles. And this is not just about one part again, repeating it again and again, but it's not just about estimating that at one instant, but creating a tool that will help us identify the migratory patterns and help us identify the localization of such kind of species based upon their characteristics. And that's where the modeling and simulation comes into picture, where we are looking at the chlorophyll content in the water. We're looking at other parameters that helps us identify what are the regions where these marine species are to be found. Environmental impact and aquaculture. Environmental impact more so from the perspective of urban flood mapping is something we're integrating into the MSP tool. Again, it involves hydrodynamic modeling using the digital elevation model, the rainfall data, the drainage system in the region, and so on and so forth. So that allows us to create such kind of simulation, which allows us to identify what kind of regions are going to be potentially flooded, which amongst that region is affected by a cropland, and which of the regions that are being affected is an urban affected region, and so on and so forth. This is extremely crucial for any kind of mapping or risk management from a risk management perspective. Area production and yield analysis. Now, shrimps. Now, we are one of the largest exporters of shrimp in the country, and it contributes significantly towards the blue economy. We created a simple regression model. Again, a lot of these solutions do not require us to have extreme computations because of the aspect of simulations, but again, that also because of the usage of machine learning and regression models that we can use to identify these. Now, one of the notable things we identified with our coastal visits was that a large subset of farmers believe that increasing the stocking density uh, directly increases the total biomass that they receive from production. So the idea for them was they try to increase the stocking density of the pond. In the pond, they add as much amount of shrimps as possible, increase the stocking density. But they do not have this idea that how much amount, what are the different kind of parameters that allows us for a better growth. So we created a regression model and integrated that, in which as a user, as a farmer, you can essentially feed in parameters, the temperature, the stocking density, the salinity, the pH, the dissolved oxygen. And what we end up doing is we end up predicting what kind of growth are we looking at, what kind of survival percentage and biomass are we looking at. And we established a study on top of the work that we had done on that. But this is again an important aspect of marine spatial planning, where we enable the community to to increase their productivity. Maritime safety and security is another element that we are adding. We have so most of the data that we obtain from SAR images, satellite data, being able to identify the ships that are present in the region, what are the different classes of the ships, and overlapping that with the shipping noise. Essentially, so using that and the satellite AIS data, it allows us to identify which of the ships have their AIS transponder disabled. Now, again, the accuracy takes a beat when we are looking at satellite, considering the fact that there might be some classified vessels who will not turn the transponders on, and of course, that also applies to fishing vessels which are lower than a certain gross tonnage. But at the same time, from a cost-effective solution perspective, this is something that works tremendously in our favor as compared to the existing solutions that we have. And of course, being having that mapping of all the uh, undersea cables, and also being having the data of seismic activities and seismic events, it allows us to identify what exactly is going to get impacted in terms of calamity, and that helps us for better risk management. um, right now, so while we have all of this, the idea is also to use AI for estimating, or to make the forecasting aspect better. So AI driven flood forecasting using hydrometry, Again, I spoke about how we've used neural network for estimation of transmission loss, creating a model for that. Sediment transport modeling, again, AI-assisted plume dispersion is something we're looking at. Vessel path prediction, it's a very common problem that has been solved in the past, but integrating that with a broader component of marine spatial planning uh, gives give all the different elements in a single tool. And that's what we are aiming at with this particular tooling that we've created. So I'd like to end with this message that for India, technology-driven MSP is not just a best practice, it's a strategic necessity. Again, borrowing from what Catherine has already mentioned, we have extreme variability. Our coast faces a high variability in climate and biodiversity. There's a seasonal fishing, there is festive tourism, things that do not even depend upon uh, that cannot be scientifically explained in the sense that you'll have tourism that happens during some festival seasons, you'll have fishing activities that will be happening during some festival season, regardless of whether they obtain a good catch or not. These things needs to be integrated into a system when we look at any kind of policy making, and the MSP tool that we're creating is specifically from that perspective, that community engagement comes into picture where we take all of that into consideration. And again, from a resource constraint perspective, India cannot afford a blanket deployment of expensive monitoring systems. Simulation-based MSP offers a very cost-effective solution from that perspective. All the data that we have in terms of, it's not that we do not collect data, it's just that the data that we have is spread across different agencies. So having a single tool where all the agencies can come and interact together, can provide, that then can upload data and then have that kind of a community engaged data sets allows us to to think from a better and a holistic policy overview. And it also, from considering the governance complexities, like the MOES and MOFCC authorities have mandates that are overlapping in these aspects, and taking into consideration the new regulations brought up, not the new regulations, but the IMO regulations on reducing the noise level and improving the habitat in general. It is being enforced more and more as we throughout the upcoming years. And we as a country, I think we need to take that up seriously. And MSP tooling or a decision support tool is extremely crucial for us to implement the marine spatial planning. Right. With that, I will wrap up my presentation. Thank you.